Welcome to virtual GED class. We are continuing our discussion of data analysis, talking about percent problems today. Today we're going to deal with percentages rather than using all the tricks that we learned last class. We're going to do what's known as direct translation. We're going to take these problems straight from the language of English into algebra, and then we're going to solve them like algebraic equations or simplify them as needs be, but we'll let the algebra determine it once we translate it into algebra. So we're going to really draw on these algebra skills. So if you've never been through an algebra unit, you might want to hit that up before the video. But Serenity's with me and she has done algebra, woo woo, so we should be good at this. Let's first just make sure that we know how to solve some pretty simple one-step equations. Okay, let's give it a try. This is really the base skill you need in order to deal with percentages this way. First thing I want to show you is if we have a problem that looks something like this. So, Serenity, do you remember how to solve an equation of this nature?
Maybe not.
I want to get x alone. Right now, x is not alone on his side of the equal sign. There's a number hanging out, isn't there?
That would be
See that number?
0.25. So
exactly. In order to isolate, to get rid of things, we need to be able to do the opposite. So we can't do the opposite until we know what's happening. What is that 0.25? What is that 0.25 and that x doing? What are those two numbers doing right now?
Multiplying.
Say that again. I just
multiplying.
That's right, they're multiplying. Serenity, how could you tell they were multiplying?
Because it's 25.
Yeah, they're all shoved together with nothing between them. So we're going to do the opposite. We always do the opposite. So the opposite of multiply is?
Dividing.
Divide. So I'm going to take this and I'm going to divide by that 0.25 so that it will go away so that my x can be alone. Now, this is why we can only do this with equations. Because the deal with equations is as long as we keep the two sides equal, we could do whatever we want. So to keep the two sides equal, I'm going to balance my change. I'm going to come over here and do the exact same math so that the two sides of the equation will remain balanced. And I've been searching all around and looking all around because I've been looking for my TI-30XS because I am not going to multiply and divide decimals by hand, because if I was doing this on the GED, whether it was the science, social studies, or math test, I would have a calculator. But something really interesting is going to happen when you divide 15 by 0.25. I actually don't need a calculator to do this, where we get 60. So 15 divided by 0.25 gives me 60. That's what I got on the left-hand side. And then on the right side, multiplying by 0.25 and dividing by 0.25 are opposites, so they cancel, and all I have left is x. And I can solve a one-step equation. So things like this will come up as we're going to do direct translation. So just super important we know how to solve those types of one-step equations here. One other skill that we're going to need to be able to put this together is we're going to need to be able to deal with that percent sign. So when we hear the word percent, I don't have a translation for that right now mathematically, and so I need a translation for that. We actually talked about that last class, what percent means. We said per means the same as divide, right? To per something is to divide it. And then cent, like a century has 100 years, cent literally means divide by 100. So when you see the word percent, you can literally divide by 100. That's what it means. So like, for example, if I saw the number 45%, one way to think of that would be as 45 divided by 100. Now, something really cool happens when I divide by 100. It's super easy to do. Now, you can do it in your TI if you don't believe me. But if you do, you're going to see that you get a 0.45. Same exact number. The only difference is instead of a whole number 45, I now have a decimal 0.45. Basically, I've lost 2 decimal places worth of value. And hopefully we know this from when we were multiplying and dividing with powers of 10. All that happens when we multiply and divide by things like 10, 100, 1,000 is that decimal places move. Okay, so basically 100 has 2 zeros in it, so I'm losing 2 decimal places worth of value. So instead of 45 having a decimal at the back like a whole number would, it moves over once, twice. And I see it losing 2 decimal places worth of value. I can use this super easy trick for dividing by 100 to really quickly convert a percent into a decimal. Let's take a look at another example. 225%. 225%. Well, If I had a number like this, it would be really easy to percent it to divide by 100. All I would have to do is take the decimal from where it's at. That's a whole number right now, so it's at the back, and move it once, twice, and I would see that that's the same as 2.25. Now, if you don't believe me, you could always do that in your calculator. 225 divided by 100, that's what percent means, and you could see I'd get 2.25. Okay, let's try one more that students usually do wrong. Students tell me all the time that 5% is the same as 0.5, and they're a liar. Let's check it out. If I had 5%, again, to percent 5 means to divide it by 100. So I would take the decimal from where it's at, move it once, twice, and I would get 0.05, or it should make sense, 5 hundredths. See how that 5's in the hundredths place? Of course it is, because I took 5 and divided by 100. I took 5 and divided it into 100 pieces. It's 5 hundredths. Real quick trick to deal with a percent, turn it into a decimal, and that is to lose 2 decimal places worth of value. Okay, so let's write this, and I'm going to call that getting rid of a percent sign. To get rid of a percent, we're going to do the implied division, and we're so stinking lazy that we won't even do it by hand. We're going to do it by moving the decimal place 2 places to the left, by losing 2 decimal places worth of value. As my decimal moves off to the left, my number gets smaller and smaller. That's what I mean by losing decimal places worth of value. Just that my number is getting smaller without any of the digits changing. Let's try one more example, because sometimes it throws students when there's already a decimal. They're like, oh crap, how can I convert a percent into a decimal if it's already a decimal? Yeah, we're overthinking things. So like, let's look at 2.35%. These are the kind of like percentage rates that you're sometimes offered on savings accounts or high interest savings account. They'll say like it's 2.35%. Well, what does that mean if we use that percent sign? So literally percent means divide by 100. So the quick, easy way to divide by 100 is to take that decimal from where it's at and jump it once, twice. Now you can see I have a blank. I fill in blanks with 0, and that's the same as 0.0235. Notice the percent sign's not there anymore because I used it up. I percented the number. I divided by 100. Let's go ahead and use this now to do some kind of straightforward percent problems. So the other day we learned to do all kinds of nifty tricks. You know, I taught you that wonderful trick when it was 10%, you could just move a decimal. When we were finding 50%, we could do half, and we had all these great, wonderful tricks. And then James at the end of the lesson said, Kate, but what about 15%? And I said, James, hold it. I don't have a nice trick for 15%. Okay, and so what do I do when I don't have a trick? Yeah, all those mental math tricks are great, but I don't have a shortcut way of figuring out 23.7%. That's just ugly. That's not something that I have mentally memorized. And so, I put an extra percent on this problem. Serenity, can you erase this for me? It's not supposed to have a percent sign at the end. So anyway, that all well and good to have a nice trick when you have one, but what about when you don't? And so one way that we can deal with this is to directly translate this into an algebra expression, an algebraic expression. So let's do that, okay? So the first thing you're going to notice is I see the word what. I have a question. It's something I don't know. In algebra, when we don't know something, we replace that unknown with a variable. What's a variable?
A letter, right?
Exactly, a letter. Now, I don't care what letter you use. There's nothing special about X. I have no idea why we overuse him as much as we do. I will use K because Kate's the best. I don't care what letter you use. You could use Z, okay, Serenity? Now, notice the next word I see. I am directly translating. I'm going word for word right here with this problem. The next word I see is the word is. And mathematically, when you get to the verb part, that's when we get to our equality and inequality symbols. So you might just see plain the word is. That's an equal sign. If you saw is greater than or is less than, then that would be a, inequality symbol. But the idea here is that when I get to that verb, I'm talking about the relationship between the two sides here. So that's going to be my equal sign. If I say that that is that, then those two sides are equal. Now I have this thing 23.7%, but I do not want to leave the percent sign in my equation. So I am going to percent this number. What did I say that it meant to percent a number? It means to divide by 100. So I'm just going to move my decimal once, twice, And by moving it twice, I have percented the number, and I've converted a percent into a decimal by doing the implied division. Does that make sense?
Yes.
Of is another word I asked you to have memorized in math class. Do you see why I said this is going to lend itself so well to algebra, Serenity?
Yes.
Of literally means multiply. People don't think that. They think it means divide. Watch out. Of literally means multiply. I'm going to bring out a parentheses for multiplication. I don't care if you wrote a times sign. We're doing the same thing. But I just don't usually use that little X because it gets confusing in the world of algebra. I use parentheses. And now, of what? Well, 50 is already a number. I can put 50 down there. And see this wonderful direct translation. What? I use an unknown. Is an equal sign. A percent, I would convert into a decimal. I could also convert it into a fraction, but in this case, a decimal was much easier. Of means multiply, and of course, 50 is just 50. And I've done a word for word literal translation. That's why I call it direct translation. And now this is no longer a percent problem. This is just a little algebra problem, and it's super, super nice because this one is already solved. Do you see how the letter is alone?
Mm-hmm.
There's nothing to solve here. The letter is already alone. All I need to do is simplify the right-hand side. I will pick up my TI. Your calculator does simplifying, and I will just do the math that it tells me to do over there. It says if you want to find K, take 0.37 and multiply by 50. Sure, I'll do that. And I get 11.85. And we're going to get a little faster and faster at the translation so that these will go pretty quickly. Okay, so we said is means equals and of means multiply. Okay, and percent means divide by 100. With that in mind, we can translate a lot of things. Okay, let's try another one. Okay, let's try what is 2% of 14. 2% of 14, not very much, not very much. Okay, I'm curious what I should translate the word what to when I'm writing in the language of algebra.
Like a variable?
Like a variable, exactly. We'll use Z this time, Serenity.
Okay.
Then what did we say is translates to?
Equals.
Absolutely. Just an is by itself, not is greater than, is less than. Just an is by itself is just equals. I'm saying one side is the same as the other. Now 2%, I can use the 2, but I shouldn't use the percent. I need to deal with what percent means. What did we say percent means?
Divided.
Divide by 100. In order
Yeah.
to quickly divide by 100, I'll take that decimal from where it exists on a whole number. It's at the back. Move it over once, twice. I'll fill in any blanks with 0. So I see 0.02. Wonderful. So that was 2 divided by 100, 0.02. And now what did we say of meant? Means multiply. And then, of course, 14 is already a number. So
Mm-hmm.
there I am. And now I have a little algebra equation. Super nice. Once again, this particular one's already solved. See how the letters alone?
Mm-hmm.
There's no solving to do. I just need to simplify the right-hand side. When I simplify the right-hand side in my TI, what do I get? There you go. 28 hundredths or 0.28. That is done. What is 2% of 14? Oh, it's 0.28. Is that cool?
Yes.
Okay. They don't have to say what is. They could say find 33. No, let's do, 335. Let's do 335% of 60. Okay, find 335% of 60. Now, this one doesn't translate to an equation. This one's just an expression. That's okay. They want me to find. Find is just kind of a generic math word. I'm just going to skip right by it, but take a look what they asked me to find. 335%. Okay, well, let me directly translate the percent, which means, what does percent mean?
Divided by 100.
Divided by 100. So I'm going to divide by 100. 1, 2. That's the same as 3.35. We said of means multiply and 60. Yeah, this one isn't even an algebraic expression. It's just an arithmetic expression. We totally know how to do that math. We can do 335% of 60. 3.35 times 60 equals 201. So love this method for this and also even for word problems. So let's see. I'm going to make up some data, okay? I don't actually know what the survey says, but I bet it's kind of close to this. So a certain survey says that, I don't know, 22% of college students binge drink at least once per semester. And can I just say that as a mother of college students, I am not condoning this. I think this is a very bad idea. This is my official stance. If there are 7,000 students at Yavapai College, how many probably, now, you know, stats are stats. They don't tell us exactly what will happen. They tell us what might happen. So I say probably binge drink last semester. And this is why I include problems like this, or why I include this in the realm of data analysis, because we use percents a lot for statistics. This is the case of a statistic. So this is something like this could come up on your science test or your social science, our social studies test, because we're talking about people here and their behavior. Okay, so now I'm saying 22% of college students binge drink. I want to pull that phrase out. It says 22% of college students. Once again, I can use some direct translation to know what to do here. Because I know how to directly translate 22%. I know what percent means. Percent literally means divided by 100. So I'm going to divide by 100 and I'm going to get 0.22. I know what of means. Of means multiply. So I'm going to multiply that 0.22. Now times what? I'm supposed to multiply it times the number of college students. Guess what?
7,000.
Exactly. I know what the number of college students is in this problem. They told me we got 7,000 students at Yavapai College. Those are college students. Okay. And so I get that 0.22 times 7,000. And even though it wasn't as clearly stated, I'm still using my direct translation there, that skill to deal with this percentage word problem. And I could guess that probably about 1,540 students, although I think they're much better behaved at Yavapai, may have been involved in an incident of binge drinking this last semester. Again, it's a probably, because that's all statistics can ever tell us, how things usually behave, not how they always behave. Now, I like this direct translation method because it doesn't only work for these straightforward percentage problems, it works for more complex problems where we're working backwards. What really confuses students about a lot of math concepts is that we don't always ask things in a straightforward manner. Sometimes we give students what they perceive of as the answer and want them to work backwards. Algebra was totally invented so we could work forwards or backwards. So it lends itself really well to doing that with percentages. And let's look at some examples where it's not necessarily a straightforward problem. Let's say 15 is 20% of what number? Okay. With direct translation, we don't have to try to memorize. Am I multiplying? Am I dividing? Is this the one where I do this? Is this the one where I do that? Which number comes first? Which number comes second? Like we have to with arithmetic. We can literally just turn it into an algebraic equation or expression and let that do the talking and tell us what to do. So let's do that. Let's turn this directly into algebra. So I see the number 15. Numbers are numbers. I write a 15. Now, Serenity, I see the word is. What did we say that is meant?
What does that mean, equal?
It does. It means equal. So I'm underneath the word is, I'm going to put an equal sign. Now 20% is kind of half in math, half in English here with this symbol, but I'm going to get rid of that percent sign by dealing with it by definition. What did we say percent meant?
Dividing.
Dividing by 100. So if I were to divide 20 by 100, I'd move my decimal once, twice, and I would get 0.20, but you know, I'm a mathematician. I'm so lazy. I never write a symbol that doesn't matter. Do you see which symbol here doesn't matter? Trailing zeros don't matter in decimals. So I will very frequently drop that and just call it 0.2. It means the same as 0.20. It's still 2/10 and 0/100. I'm just not bragging about my 0/100. Okay, so 0.2. And then of, we said means what? Multiply. So I want to multiply. Now, interesting. Of means multiply. So I'm writing a parentheses to mean multiply. But look what I ask you to multiply by. Of, it says what number? Of what number? This is an unknown. See those question words?
Yeah.
In algebra, when we reach an unknown, what do? Put in a letter to stand in for the unknown. So oh, sorry, I messed something up in my notes along the side, if you were paying attention. Percent means divide by 100, and of means multiply. Okay, so anyway, I have an unknown. So I'm going to use a letter for an unknown. No, I do not care what letter you use. You could use W for what number. You could use N for number. I don't care. Okay. Now, I hope that this right-hand side of the equation looks a little funny to you, not because it's wrong, it's totally right. 0.2 times n can be written that way. But most mathematicians don't write it that way. You know how lazy we are. We never write a symbol we don't need to. And we know that if you want to multiply together a number and a letter, you do it by just shoving them
Together.
real tight. So I would probably have written it just like this. Now I'm going to leave this step here because a lot of students need to see it to understand where my next step came from. But a mathematician would go straight to this bottom line that I have written out. 15 is 20% of n times n. Okay, so now notice that in this case, my letter is not alone. Before, my letters were alone, so all I had to do was simplify. But this time, look at my n over there with a number. We can see that there's still a number hanging out with my letter. And so now is when I need to bust out my solving skills. When the letter's not alone, I have to solve. Serenity, how could I solve something like this?
Wouldn't you divide the, pretty much you're trying to get the 2 away from n?
Absolutely. So I'm going to divide by what number?
2.
0.2 or 2
0.2,
tenths. Wonderful. And the rule of solving equations is as long as I keep the equations balanced by doing the same thing, I can do whatever I want. So I'm going to keep that equation balanced by jumping over here and dividing by the exact same number. Now we'll see what happens. If I take 15 and divide by 0.2, I get 75. That was what I saw on the left-hand side. I'm just simplifying. And on this side, multiplying by 0.2 and dividing by 0.2 cancel so that my n is alone. So 15 is 20% of what number? It's 20% of 75. I just solved my equation for the unknown number. Does that make sense?
Okay, so the 0.2, does it move or is it just automatically 75?
I got 75 from doing this math in my calculator, Serenity. I took 15 and divided by 0.2. That's what I said I would do, and that's what I did. And when I did, I got this simplified answer of 75. So it's not that the 0.2 went away, it was used. It was used in an act of division. Does that make sense?
Yeah.
So that was on the left. And then on the right, my 0.2 did cancel because multiplying by 0.2 and dividing by 0.2 are opposites, they cancel out. So it's like gone. I mean, even if you did it in your calculator, 0.2 divided by 0.2, you'd see it goes to just one n. And there I have one n sitting right there. Does that make sense?
Yeah.
Let's try another one like that. 135% of what number is 16? Okay, and I have no idea if this is going to be nice or not. I'm sorry. Should have written these problems in advance. 135% of what number is 16? Okay, let's go ahead and directly translate this statement that we see. So first thing I see is 135%. Serenity, I can't have a percent sign in my equation, or I suppose I could, but I would not recommend it because it confuses the crap out of you guys. So let's deal with that percent sign. What do I get when I percent 135?
1.35.
135 divided by 100 is 1.35. I just lost 2 decimal places of value. And what did we say that of meant?
Multiply.
Multiply. But look here, I'm multiplying by an
Unknown number.
unknown. Exactly. And so to do that, I'm lazy. I'm just going to shove up the unknown real close to the other number. That's 1.35 multiplying with an unknown. Cool. Next thing I have is the word is. We said is meant equals. And then, of course, 16 is 16 in English or math. English or algebra, I guess I should call it. And there we go. I've translated an English statement into an algebraic statement. We've got an equation. Okay. Is my letter alone? No, it's time to solve. How could I solve something like this? I think you said I need to divide. And if you did, indeed, you're right. I want to separate that multiplication relationship. I want to break up an act of multiplication. We do it by doing the opposite, division. I can do whatever I want to an equation as long as I do it to both sides. So there we keep our balance. On this left-hand side this time, multiplying by 1.35 and dividing by 1.35 cancel, leaving me with just that n dropping down. And on this side, here's my ugly division to do. I think my calculator is going to yell at me. It sure did. I got this long, ugly number.
Hmm.
I told you I should have written my problems in advance. I think it's 8.51 repeating.
Yeah.
I see a pattern, 8.51, 851, I mean, 0.851, 851, 85. I'm guessing that's going on and on forever. I'm just going to assume it does. Now, guys, if this were really on the GED, by the way, this little bar just means repeating pattern with decimals. If it were really on the GED, I don't usually see that bar. There would probably be rounding directions, but since I forgot to give Serenity any rounding directions, we're just going to leave that answer right there exact the way it is. Interesting other kind of problem that I have, but in order to do it, I need to talk to you about this concept of if we can move forwards in math, we can move backwards in math. So here we go. I want to talk about conversions. Now, the word conversion in math means flipping from one equivalent, so equal, form of a number to another. So I'm moving between equal forms of a number. You guys are used to converting between like fractions and decimals, right? Like 1/2 is the same as 0.5. 0.5 is the same as 1/2. That's a conversion, okay? Those two things are totally equivalent. They're equal, just different forms. Okay, so we just did conversions between percents, and I'm going to call it standard form. Some teachers say percents and decimals, but because that confuses students a lot, I'm just going to say the standard form of a number, regular numbers. Okay, so that's what I mean when I say standard form, regular numbers. So for example, you already told me that if I had 27%, for example, I could rewrite that as just a regular number without a percent sign. We've done that already many times. So how would I write that using a decimal?
You would just do 0.27.
Exactly, 0.27. Let's do a couple more to make sure we're good at this because we're about to flip it around. So how about 4%, one that students often mess up? If I wanted to write this without the percent sign as just a standard form of a number, what would that convert into?
0.4.
Careful, not 0.4. You divided by 10. I need you to divide by 100. Move that decimal once, twice, and I get 0.04. And I did that one for that very reason, Serenity, because you wouldn't be alone. Most students get that wrong. So careful. It's not just move the decimal to the left. It's move the decimal 1, 2 times. Okay. So let's try like 360%. Think of where the decimal's starting, and it's going to move exactly 2 times because percent means divide by 100. Percent doesn't mean put the decimal in the front. It means divide by 100. So I'm going to lose 2 decimal places worth of value. Where's that decimal going to end up?
Isn't it going to be 3?
Exactly, 3.6. And Serenity, if I really wanted to, I could include that 0 back there. But we talked about this before. Trailing zeros, ones at the end, don't matter.
No.
Oppose that to sandwiched zeros. See this 0 that's sandwiched between the decimal and the 4? That one matters because it's holding 4 in its place. So let's talk about a synopsis here. What did we say we were doing on all these problems here? We said that we were dividing by 100. And when we divided by 100, we lost 2 decimal places worth of value. I want to be real clear about what was happening there so that when we go to do the opposite, it's real easy on how to reverse it. What if we want to go now, instead of from percents to standard form, what if we want to go from standard form to percents? Exactly. Well, we should do the opposite. So let's think about the opposite. We're algebra students by now. We ought to know the opposite of dividing by 100. The opposite of dividing by 100 is?
Multiplying.
Exactly. So if we want to convert back the other way, we are going to multiply by 100%. 100% is just 1, right? So multiplying by 100% should not do anything to my number, and it will not. It will not change the value of my number. My number will continue to be equivalent. It will just be in a different form, right? So I'm going to times by 100%. Now, if we said that dividing by 100 was like moving left with the decimal twice, guess what? Multiplying by 100 is going to be like moving right twice. Again, we see this opposite principle. The opposite of left is right. So instead of losing 2 places of value, we're going to gain 2 places of value. So let's try converting some numbers that are in standard form into percents. I'm giving myself some directions. Okay, so for example, the number 34 is just a number. That's just a plain old number. If I wanted to convert this into a percent, the math that I would be doing, even if I don't write it, okay? So you don't necessarily write it, but I'm going to write it right now so you can see what I'm doing. I'm basically multiplying by 100%. Now, why does this work? We said in our last video, our intros to percent videos, that 100% is just one whole thing. So whether you think about it like this or not, when I multiply by 100%, I'm just multiplying by 1. And 1 does jack squat when I multiply. It doesn't change value. So even though the number is going to look different, it's going to be in a different form, its value will remain exactly equal. 34 times 100% would be 3,400%. Might seem big to you, might seem unnatural, but it's true because I'm going to multiply. Now that makes sense because we said that like 200% was like 2 times as much, 300% was like 3 times as much, 3,400% would be like 34 times as much. Okay, let's try one a little smaller, like 0.6. Now, if I wanted to take, again, a plain old regular number, standard form, and convert it into a percent, the way to do that would be, again, to think about multiplying it by 100. Now, I don't have to do any side work to do this because I know what happens when I multiply by 100. I gain 2 decimal places worth of value. Now, I forgot to show it here, starting at the back, jump once, twice. But I'll show it directly here. Jump once, twice. See how I jumped once, twice? It's not going to be 6. It's going to be 60. So 0.6 is the same as 60%. Okay, let's try an easy one that I probably should have started with. 0.13. Now, you know, mathematicians are just lazy as can be. I'm not going to write times 100 every time if I know what happens when I times it by 100. So the quick, easy way to times by 100 is just to gain 2 decimal places worth of value. So I'll jump it once, twice to the right. And I highly suggest that if you're trying to memorize this, you memorize it as gaining or losing value, not left or right. Because students who just memorize left or right give me nonsense answers, mix up when it's left and when it's right, and give me funky answers, okay? So 0.13 is the same as 13%. I'm just taking this exact same skill and applying it backwards. Now, here's one that most students screw up. If I wanted to convert 2.4 into a percent, again, I would need to gain 2 decimal places worth of value. So my number needs to get more valuable. So I'm going to move my decimal place this way. Now it's 24. It's more valuable than 2.4. Once and now twice. So now it's 240. I gained value. My digits remain the same, but I gained place value when I move that decimal twice to the right. Now 240 what? 240%. So I kind of think of this like taking off a percent sign. To take off, you lose value, and then to put on a percent sign, you gain value. Let's use that. We're going to need that last little skill to do the last kind of percent problems that I have to offer today. Let's say, I keep using 15. Let's try a better number. I don't know why I'm so obsessed with 15 today. So 12 is what percent of 16? Okay. So this problem is still a direct translation. I can still deal with it, I should say, by direct translation. I could turn this kind of like half math, half English statement into an algebraic equation, okay? And I can do it by directly translating each one of these things I see. So 12, of course, is just 12. Next thing I see is is. How did we say is would translate, Serenity?
Wouldn't that just be equals?
Equals. Now, this next phrase I say is what percent. Now, there's a couple of ways that I can deal with that. What percent? We know what those two things mean separately. We know what means, where it's an unknown, right? We would use a letter. And we know what percent means. Percent literally means divided by 100. Okay, so I could deal with those separately. I could write it like this. What percent x divided by 100? I could do that. And now we know what of means. Of means what?
Multiplying.
Of 16. So I can totally do it this way and it would work. But a lot of students don't like the fraction in there. See the fraction? Exos freaks students out. So I'm going to show you, and they give me the exact same answer. Okay, I'll solve them both. But I'm going to show you one other way to deal with this, and it's still direct translation. Okay, it's not something new. But I still could do 12. 12 is, now this says what percent. I could just call this a P for now and deal with the fact that it's a percent later. Okay, and that's what I will do for this one. Okay, now I want that P to multiply by 16. Now this is a true statement, but it's not written the way mathematicians usually write this, because we usually write the number first and the letter second. So most mathematicians would write that 12 is equal to 16P. Same exact difference. Those two equations are exactly equivalent. It doesn't matter what order you multiply in. And this one looks more normal to us, so most students now know how to solve it. Okay, so notice my letter P is not alone. I want to solve it. What would I get if or how would I solve for P here? Help me out.
You put 16 on both sides.
Yeah, how do we want me to put it? Add, subtract, multiply, or divide? What shall I do with 16 on both sides? Divide. And I'm doing it on both sides so that my equation stays balanced. Now on this right-hand side, multiplying and dividing by 16 did cancel, so P was alone just like I wanted. And on the left-hand side, that's calculator work to do. Make sure when you type this in the calculator, you type it in the right order. 12 divided by 16, not the other way around. And I do get 0.75. Okay, now my only warning about this method is be careful. I have not yet dealt with the fact that this number is actually a percent. It's supposed to be a percent. Well, we just talked about how we could, right now it's in standard form. There's no percent sign. So we're going to have to take an extra step to convert it from standard form to a percent. Well, we just said on the last screen that if we wanted to convert from standard form to a percent, we would gain 2 decimal places worth of value. We would multiply by 100%. So that is what I'm going to do. I'm going to take my decimal from where it's at, and I'm going to move it twice to the right, boom, boom, so that my 75 gains 2 place values, or 2 spots worth of place value. So then that is the same as regular plain old 75%. And now it's not in standard form. Now it has the percent sign. My percent is 75%. Now, I just to prove to you, because you can ignore the left-hand side. In fact, if you hate me for teaching 2 methods, some people do, you could just forward through this video. Serenity doesn't get that luxury. But I just want to prove that good math always works, okay, whichever way you dealt with the percent sign. So just an FYI, even if you had done it this way, I would have gotten 16x over 100. I'd multiply by 100. That'd be one thing I could do, because multiplying by 100 is the opposite of dividing by 100. This problem just isn't as straightforward, but it would give me the same answer. So I do that on both sides. Then I'd get 1200 is equal to 16x. And then to solve this, I'd need to get x alone. I'd divide both sides by 16. And you would see that I would still get x is equal to 75%. 1200 divided by 16 is 75. So I'm still going to get the same answer, but usually the right-hand side is more intuitive for students. Find it first and convert it afterwards, instead of dealing with the percent sign at the beginning. So I'm going to just continue with just using the right-hand side method. Okay, so let's try now some more examples. Okay, so what percent of 25 is 15? We can directly translate this into an algebraic equation. I know it's an equation because the word is tells me we got that equal sign. So what percent of 25 is 15? Okay. Well, first I see what percent. And I told you that I was just going to use a P for percent to help me signal that I'm going to convert it to a percent at the end. Now I say what percent of 25? Of 25 means times 25. If I want to times together P and 25, I just write the 25 first and the P second. Is that good for you? Now I'm being really lazy like a mathematician. And then I see the word is, and I know what is means. Is means equals. So what percent of 25 is 15. Very simple little one-step equation to solve. On the left-hand side, multiplying and dividing by 25 cancels so that my P is alone just like I wanted. And on the right-hand side, remember to go in the exact order when you type into your calculator. That fraction bar is a divide by sign. So 15 divided by 25 is 0.6. Now I kept that P to remind me as my final step, I better convert from standard form to
Percent form.
Exactly. Now, do you remember how to convert from standard form to percent form?
You times it by 100.
Basically, exactly right. The work that I'm doing in my head whether you think about it like that or not, is timesing by 100%, which is just 1. And if I were to do that, I'm going to gain 2 decimal places worth of value. My 6 is going to get more and more valuable. Once, twice, that's a 60%. So P is equal to 60%. So the only way it could really get trickier, Serenity, is if I start mixing up like those 3 kinds of problems that we just looked at. So let's try it. Let's mix them up. Okay. So what is 3.5% of 15,000? We'll deal with 3.5 is what percent of 150? And we'll say 3.5 is 20% of what number? Okay, all the concepts we learned today mixed up, but they all can be dealt with direct translation. So let's try this first one. What is 3.5% of 1,500? Can you help me translate this into algebra? So first word I see is what?
The variable letter.
Then I see the word is. Is means equals. What is? Okay, what is? And then now maybe that's what you meant for divided, because I have 3.5%. So 3.5 divided by 100, so I'm going to lose 2 places of value. So I'll get 0.035. And then what did we say of meant, Serenity? Everybody always forgets what of means. They think it means divide, but it doesn't. What's it mean? Multiply.
Yeah, multiply.
And 3.5% of 1,500. So notice my x is already alone, so I don't have to solve. This is solved. I only need to simplify. There's work I know how to do on the right-hand side. And so I can simplify in my calculator. 0.035 times 15,000 is 525. So in this case, x is equal to 525. Okay. Now let's try direct translation of the next statement. 3.5 is what percent of 150? Help me to write that as an algebraic equation. 3.5, the number, is just 3.5, the number. And now what do I see next after 3.5? Is means
Equals.
Cool. Now I see what percent. So a mystery percent, we said we'd use a P for ourselves. Okay, I'm going to write it up above because P is supposed to be doing what with the number 150? What does of mean?
Multiplying it.
Multiply. So I'm going to write it this way, 150P. What percent of 150? Are you cool with that?
Yeah.
Okay, cool. What should I do to this? In this case, the letter is not alone, so I need to solve. How do I get this letter alone?
Divide 150 on both sides.
Exactly. And we can see there's the work to do on the left-hand side. That's so calculator work. 3.5 divided by 150 is gross. I should have given you rounding directions again. I got 0.0233333. I'm just putting ... And then on the right-hand side, that's equal to 150 divided by 150 cancels out, so that P is alone. Now on a problem like this, we said we'd use the P to give ourselves a hint to do something else. Do you remember what I still need to do? Convert to a percent. Yeah. This is a number in standard form. I want it as a percent. In order to get it as a percent, I'm going to gain 2 decimal places worth of value. I'm going to multiply by 100. Move that once, twice to gain value, and that is the same as 2.3%. Okay, now let's try the last one here. It says 3.5 is 20% of what number? Help me write that as an algebraic equation, Serenity.
So wouldn't it be 0.35?
3.5. There's that part. Next word is
Equal.
Wonderful. Get rid of a percent sign by jumping once, twice.
So 0.2 or 0.2.
Exactly, 0.2. Then it says of what number?
So that'd be just like times a letter, pretty much.
Times a letter, exactly. Okay, cool. Now we'll let the algebra guide us. According to this algebra right here, what should I do, Serenity?
Technically get x alone, so put 2 on both sides.
Exactly. I want that x alone. I want to solve. I'm going to divide both sides by 0.2. On the left-hand side, 3.5 divided by 0.2 is 17.5. And on the right-hand side, multiplying by 0.2 and dividing by 0.2 are opposite, so they cancel. All I have left is that lone x. I have done my duty here. 17.5 is equal to x. So thank you for joining me for today's class on percentages and using our algebraic skill of direct translation to solve percentage problems. Join us next time. I actually thought I was going to get more done today, so I think next time we'll work on some multi-step percentage problems. The GED does say that you'll have those. They're on the calculator section, so bring your calculator with you. We'll look at some tax, tip, and discount word problems using our TI-30XS calculator. All right, thank you for joining me. So glad to not be talking to myself, and see you next time.